Hi, everybody. Welcome back to Dave's Math Channel. I'm your host, David Tare, and this is my continuing feature on the Math Lovers book. And I'm on section 4.3 of volume 1, which is on complex arithmetic. And today I'm going to talk about complex square roots. This is the most complicated piece of complex arithmetic I'm going to talk about, at least in this section. Anyway, let's begin. So, what I'm going to do today is I'm going to derive a formula for how to calculate the square root of an arbitrary complex number. How would you do that? Well, we start like we always do. We start with a number we want to take the square root of, which I'm calling x plus iy here. Sometimes we call it z, but z is x plus iy, where x and y are x is the real component, y is the imaginary component. And since this is going to be a complex number, we can write it as u plus iv for some unknown real numbers u and v. U is the real component of the square root, and v is the imaginary component. And as you might imagine, the first thing we want to do here is square both sides, get rid of the square root. And if you do that, you get x plus iy equals u plus iv quantity squared. And I already talked about how to square complex numbers. I gave a formula for it a few lessons ago. Let's talk about complex multiplication. The formula is u squared minus v squared. That's the real part. And then the imaginary part is 2uv. So you get u squared minus v squared plus I times 2uv. And I think you guys know that two complex numbers are equal if and only if the real and imaginary components, respectively, are both equal. So that means that x equals u squared minus v squared and y equals 2uv. Well, this is nice because now we have two simultaneous equations and two unknowns, so we should be able to solve them. It's a little bit complicated here because these are nonlinear. It's always harder working with nonlinear equations than linear equations. But it's not too bad. The first thing we want to do is solve for v in terms of u. That's pretty easy. Just take the second equation here, divide both sides by 2u, and if you do that, you get v equals y over 2u. That's the first equation. That doesn't solve for v. It just solves for v in terms of u, but we can use this equation. We can substitute that equation into the first equation to solve for u. So that's the next thing we're going to do. So if we do that, we start with the equation x equals u squared minus v squared. That's what we had before. But now we're substituting y over 2u for v. So then we get u squared minus y over 2u quantity squared. And if you simplify that, you get u squared minus y squared over 4u squared. Okay, now we multiply both sides by 4u squared. And if you do that, you get 4xu squared equals 4u to the fourth minus y squared. Now we can write this as a single quadratic equation in u squared with 0 on the left side. If we subtract both sides, 4xy squared from both 4ux squared from both sides, we get 0 equals 4ux squared. Or no, I'm going to do this right. U is 4u fourth minus 4xu squared minus y squared. And that is a quadratic equation in u squared. We can apply the quadratic formula to solve for u squared. I'm not going to go through all the steps here. But if we do it, we find that u squared equals x plus or minus square root of x squared plus y squared all over 2. So that's a formula for u squared. And now all we have to do is take the square root. But you have to be a little bit careful because there's two square roots. There's always two square roots of every number. One positive and one negative. We don't know whether u is going to be positive or negative. As a matter of fact, there's always two square roots, so we have to keep both of them. So in the end, what we're going to get for u, this is equation 4.3.10, u equals plus or minus square root of the quantity, the fraction square root of x squared plus y squared over 2. That is the formula. Or I'm sorry, x plus, square root of x squared plus y squared plus x over 2. So that's the formula for u. And now, if we want v, we just apply the other formula 4.3.9, which has v in terms of u. We can substitute for u the equation we already found. I'd rather not write an explicit formula for v in terms of x and y. The reason I don't want to is because it depends on the sign that we chose for u. It's better to use it in this form. Anyway, those are the formulas for calculating the square root of an arbitrary complex number. I know they look kind of ugly, and I didn't give any examples in my book, and it probably is a good idea to go through an example here. So let's just try an example to see what we get. Let's start with z equals 3 plus 4i. So in other words, x is 3 and y is 4. Let's see what we get. Well, the first thing we're going to calculate is u, and I picked this example because I think you guys all know 3, 4, 5 is a right triangle. These are the 3 and 4, the legs of a right triangle with integer sides, and I think you guys all know the hypotenuse is 5. So if x is 3 and y is 4, then the square root of x squared plus y squared is 5. So now we're going to get 5 plus x. X is 3. So we're getting 8 in the numerator. We have a 2 in the denominator. So we're going to get square root of 8 over 2. 8 over 2 is 4. Square root of 4 is 2. But we also have the plus or minus. That means u is plus or minus 2. Well, that's nice. Now we got u. Now we just have to get v. And v, remember, is given by this other formula. V is y over 2u. And remember that u is plus or minus 2. So y was 4, so we're going to go 4 over plus. Did I do this right? Yeah. No, y over 2u. So we're going to get 2u is plus or minus 4. So we're going to get 4 over plus or minus 4, which is plus or minus 1. And the plus or minus are the same for u and v. That means that if u was 2, then v would be 1. And if u was negative 2, then v would be negative 1. So our square roots are going to be 2 plus I and minus 2 minus I. Those are the two square roots of 3 plus 4i. So that's an example. And you can try this with the legs of any Pythagorean triple. I just picked 3, 4 as a simple example. You can try another one for yourself if you want, just for fun. Anyway, that concludes my video on how to compute square roots of complex numbers. Thank you for watching. Long live math, and I'll see you guys next time.